Sorry. What I don't have to match it. I had that too. What? I think that was mine. I think you're lying.
All right, so 24, right?
Did you say 24, 25?
24, yeah.
All right, so this is definitely a little different than most of the inequalities in this section. You've got a double inequality, and it's 0 less than 9x minus 36 all to the negative first, which means it's really 1 over 9x minus 36, less than 1/9. Now, so the first thing is any double inequality. I'm just going to write a real simple one over here. If I had 3 less than x less than 5, all double inequalities can be broke up into a compound inequality. A compound inequality is two inequalities that are adjoined by a word, either or and.
Madison Hall, please report to the new office. Madison Hall, please report to the new office.
If it's and, then the solution set has to solve both inequalities. If it's or, a number only has to be able to satisfy one or the other. All double inequalities can be broke up like this. So you can say x less than 5 and x is what, greater than what, 3. So a lot of the double inequalities that you solved, you didn't have to break it up into the two inequalities joined by the word and. This one, we're going to have to break it up. So that's the start. So what do we've got? We've got this 9x minus 36 to the negative first less than 1/9 and 9x minus 36 to the negative first greater than 0. And we're going to have to we'll solve each separately. All right. And the reason we're going to have to do this is we're going to have to employ a reciprocal property on one of them, so which is technique wise different than the other. So we'll start with this one. So as I said, because of the negative first power, that's really 1 over 9x minus 36 greater than 0. Now, the deal here is by rule, looking at this one, if you have 1 over some number and it's positive, so it's greater than 0, then
Jody Taylor, please
the number
report to the
itself
new
has
office.
to be
You
greater
are
than
leaving.
0. Hey.
Jody Taylor, please report to the new office. You are leaving.
So employing that, if we have this, applying that rule, that simply means 9x minus 36 is what, greater than 0. And that's certainly a linear inequality, one variable. Take 36 over, divide both sides by 9, and x is what, greater than 4. So we're good there so far.
Yes.
All right, so we've got to tackle the other one now. So we'll rewrite this the same way. We're going to have 1 over 9x minus 36 less than, now it's not 0. It is going to be 1/9. Okay. So what I'm first going to do is I'm going to multiply both sides by the same thing. And that same thing is going to be 9x minus 36. And that's literally to get this to be really just a factor of 1. So on this side, 9x minus 36 times 1, and then here as well. So that's going to be 9x minus 36 now over 9. All right. So this is going to, by just multiplying both sides by the same thing, but it's specifically choosing 9x minus 36, that makes this again 1. And here I can factor out a 9 out of the top, which would leave me with a quantity x minus 4. And then that 9 that I factored out of the top would cancel with the 9 in the bottom. And I now have that. Okay. So I just, because I like to read it, you can do this right to left, but I prefer to read it left to right. I'm going to flip this. X minus 4 is greater than what? 1, which would imply that x, or adding 4 to both sides, x is what? Greater than what? 5. Right, good so far.
Yes.
Okay, now, so we got to remember that this was a compound inequality by the word and. So a solution, if it's in the solution set, has to satisfy both. So I need, the number has to satisfy this, has to satisfy that. So kind of doing it visually, just what do we got here? I just draw a number line. Here's 4, and here's 5. So on this one, it says any number, not including, that's the parentheses, but 4 and bigger. This one said not including the 5, but what? Bigger than 5, but not including 5. And we got to make a note of that, not including 5. So, shoot. Bear with me. So what do you think the solution, given this, what we talked about, this, a solution has to satisfy both inequalities? Looking at this graphical display, can you describe the numbers to me that would be in the solution set?
Is it greater than 5, not including 5? No, because that wouldn't satisfy the 5. I think it would be greater than 5, but not including 5.
So you're thinking it's got to be what? X is what? Strictly what? Greater than what? 5?
5. Yeah.
All right. And what would that look like in interval notation?
And we would look like an interval notation.
Interval notation.
All right, so I'm going to go ahead and write it and then tell me if this would look familiar to you. Parenthesis, just like I put on the number line, which just means don't include that value you start with. Don't include the 5. And we know the solution's then any number bigger than 5. So we indicate that by going comma. And then we use the infinity symbol.
Oh, yeah. Sorry, I knew that. I knew that.
So that is actually referred to as interval notation when you write your solution set like that. And we're going to use that a bunch when we get to functions and start talking about their domains and ranges and where functions are increasing, decreasing, so on and so forth. All that will be described in interval notation. So that's it. It's you're going to be greater than any number bigger than 5. We good now?
Yeah.
All right, awesome. Is there any others?
Okay. Taylor, you have any others?
No.
Okay. I should have led with this. How long do we got?
TJ and Abby Flood, please report to the office. You're leaving.
What time do we go to lunch?
So-
11:44.
Our lunch ends at 1:44.
No, our AA.
At 1:44.
Our lunch begins at 11:44, but we can work on past that for an extra half an hour because like right now we're in our homeroom and then we have lunchtime.
Okay.
So
Well, I don't want anyone to miss lunch. So
it's okay.
yeah, I'm not going to do that to you. So your lunch starts at 11:44. That means we have 11 minutes.
Yeah.
About
How fast can you
No,
lecture?
This is not.
All right, so this will be the world's fastest discussion on absolute value equations and inequalities. And then you can get to lunch. And what we'll say basically is I'm going to assign 1.6. Of course, the videos will be in there as well. Of course, I think I've already assigned those. And I just want you guys to get through work through all the problems on 1.6 before our next class on Tuesday.
Okay.
And then I'm going to assign a quiz and
Okay, well, Jordan, please report to the
we'll
office.
just go from Tuesday. I may want to try to meet with you on Wednesday as well and
Okay.
Thursday.
And for our tests that we will take, I know you talked about we'll have one soon. That will be only 45 minutes long. We won't have to extend it. until-
Yeah, I had already discussed, I thought I had mentioned to you, but if I didn't, I apologize. That first day I met you all. And
Okay.
Mr. I can't think of his last name. Nair?
Yeah.
Mr.
Yeah.
Nair? Yeah. And I will, I'm gonna have to redesign the test to fit within that time frame,
Okay,
which I'm okay with. I understand the biology side of it. It's hard to pair out questions. It's just a different study. And, but I don't have an issue designing a test that's gonna fit within that time frame. It does put more pressure on you because that means you've got to finish it, within that time frame. And typically, my tests are a little longer and I don't put a time limit on them. So the final, that one, we're going to have to figure out a way to get, because everybody has to have 2 hours. That's the rule for any college final.
Emily Flood, please report to the office. You are leaving. Emily Flood, please report to the office. You are leaving.
Anyway, we'll cross that bridge when we get to the final. But yes, in short answer, it will be designed to fit within your time frame.
Okay.
All right. So real quick, absolute value inequalities. I'm basically going to write the 3 rules we're going to need. I'm going to assume you know what absolute value is. Absolute value of a number is distance it is from 0, correct?
Yes.
Okay. So if I have absolute value of X, some variable, or an expression of that variable, it could be 2X plus 5 or something like that inside the absolute value. And it's isolated. So if that, and it equals some number A. Now, then, and we're going to assume here A is greater than or equal to 0. So it is non-negative. Then X, that what's inside either equals A, or it also, you can figure out what value to X put in there to make it equal to the opposite of A, because ultimately you would take its absolute value. And so for solving absolute value equations, you need to make first the absolute value term is by itself isolated. No coefficient other than 1, nothing added or subtracted outside it. So it's isolated on one side. All right. And hopefully I'll have time to work a few. Then we could have inequality. So it's going to be the same deal. Isolated the absolute value. And we'll say less than some number. Now this time I'm not going to stipulate. I only stipulated A greater than 0 here because if it's not, the equation has no solution. Here I'm not going to really stipulate this. I'm just going to say, well, if this is the case, we can rewrite it by taking whatever's inside the absolute value and writing a double inequality, literally wedging it between what's inside the absolute value and A and the opposite of A. And that's how ultimately we will solve these less than absolute value cases. Now, if you isolate the absolute value term and it's less than a negative number, you have it set less than a negative number, that is never going to have a solution. You can't take the absolute value and get a negative value. So there's no way it's, what you end up with would ever be less than A. So that's a special case. And then the last possibility is you have absolute value of X or expression of X greater than A. And here you have a compound inequality, and it's what's inside less than the opposite of that number, or what's inside the absolute value greater than that value. Are you guys familiar with the union symbol?
Yeah, but
Yes,
it was
but refresher.
confusing.
Okay, so it's a set operation. If you have two sets and you say take the union, then I always say it's just like dumping them both into a big hat. The key word is or. To be in the union of two sets, you just have to be in one set or the other. And so when you solve these inequalities, you're basically going to solve two inequalities. Those two sets are going to be disjoint. That means they have nothing in common, but it's a union. And when you input the answer into my math lab, and you hit in the field and you get the toolbar, you will have a union symbol. So you won't type the word or, you're going to type this union, the U. It's a U. And so you'll see it right on the toolbar.
Okay.
Okay. All right.
Or
So let's do let's kind of a quick example. Oh, one other thing. If you get the absolute value isolated here and you're greater than a value, such as I'm just absolute value 2x plus 5, and I'm saying I want to find all values where that's greater than -7, that's easy. I don't have any work here to do. I just look at it and say all real numbers. And that's negative infinity to infinity in interval notation. Reason being is I don't care what you put in for x, multiply by 2, then add 5. You're ultimately going to take it's what you can put -1 million in there, but ultimately you're going to take the absolute value, which will always be greater than a negative value. If we had negative x, absolute value of -x minus 5 greater than or equal to 7. Right, so first make sure the absolute value is isolated, then remember the rule here. And so this is going to be whatever's inside, don't change the signs. -x minus 5, you're going to be less than or equal to -7, or -x minus 5 greater than or equal to 7. And then I just algebraically solve for each. So add 5 both sides, I'd have -x less than or equal to -2. Now you'd have to multiply both sides by -1. Remember, if you multiply both sides of an inequality, inequality will flip. So this will now be x is greater than or equal to 2. Here we'd have -x greater than or equal to 12, adding 5 both sides, then multiplying both sides by -1, we'd have x is less than or equal to -12. So in interval notation, this would look like, I'm going to take this one from -infinity. This just indicates come from the left on a number line up to -12. Now because it's or equal to.
New office, you are leaving. Florida Snodberg, please report to the new office. You are leaving.
Use a bracket to say include -12. And this is where I'll use that union sign. We'll union that with then bracket over here from 2 on.
Okay.
Yeah, I remember that.
Are we okay with that?
Yeah.
Yeah.
wait a second.
Okay. All right. You will run into a couple absolute value equations that look like this. There will actually be 2 absolute value terms. But you would actually solve these using the same rule. You would write 2 equations. You would take what's inside here and set that equal to what's inside there. And then the second equation will be what's inside here. And I just do this thing. You can do it right to left, but I think left to right. But this time you say the opposite of what's inside here. So opposite of 2x minus 3. Then you have 2 linear equations here and you solve each, and whatever solutions you get out of those will be your solutions to the equation. All right, it is 11:43. So, again, what I'm going to assign, is just an addition to what I have, the 1.6 homework,
Okay.
which is absolute value equations and inequalities. And I will put the due date on that to be Tuesday. So
Okay.
between now and Tuesday, let's work through everything that's assigned, bring questions. And because what we're going to do on Tuesday at that point is review back through. I'll talk a little bit about the test. I'm going to assign a quiz on Tuesday. And then that's why I was kind of wanting to go ahead and meet on Wednesday.
Okay.
Just in case you have any last questions or questions on that quiz. And then coordinate with Ms. Deweese and have you take your test on Thursday over chapter 1.
All right.
We good?
Yes.
Okay.
All right.
All right, guys. Enjoy the rest of your day. Enjoy lunch.
Yes,
Bye.
thank you.
Thank you.
See ya.